All right, if you're a networking Ph.D. scholar, listen up. You're about to make one of the most critical decisions of your entire research career. And no, it's not about your topic or your advisor. It's about your tool. So let's dive into this strategic showdown, ns-3 versus OMNeT++.
You got to think of your PhD like a high-stakes chess match. Choosing your topic, that's your opening move. But picking your network simulator, that's your gambit. It sets up your entire strategy, how you're going to attack the problem, and, most importantly, how you're going to defend your work later on. This is way more than just a technical detail. It's the bedrock of your whole game plan.
And here's the thing that most people miss. This choice isn't really about which tool has the fanciest features or the slickest UI. For a PhD student, it all boils down to one word: defensibility. Your simulator choice will be questioned. Does it have scientific credibility? Can you actually get in there and mess with the guts of a protocol? And the big one, will top-tier journals even take it seriously? That's the real checklist.
So let's meet the two titans in the ring. We're talking ns-3 and OMNeT++. And you need to understand, they don't just have different code bases, they have completely different philosophies about what a simulation is even for.
And this image just nails their core identities. See, on the left, you've got ns-3. It's like a surgeon's scalpel, an incredibly precise tool made for doing deep, careful work inside the network protocols themselves. Then, on the right, you've got OMNeT++. Think of it more like a set of Legos, a really flexible, modular framework for building and visualizing complex systems from a much higher level.
Let's break that down. ns-3 sees itself as a research instrument. Its entire reason for being is protocol realism. Getting the nitty-gritty details as accurate as humanly possible. OMNeT++, on the other hand, calls itself a modeling and visualization framework. Its main goal is system modeling elegance, making it easy to snap different pieces together. See? They're trying to achieve two totally different things.
Okay, so what does that philosophical split actually mean for you when you're working on your project? Well, it has a huge impact on the kinds of models you can actually use. This is the classic trade-off between depth and breadth.
This is such a great way to think about it. ns-3 is like a highly curated academic library. Yeah, it has fewer models. You'll find things like 5G and Wi-Fi 6, but they are incredibly deep, they're meticulously maintained, and they're mostly official. That means you get high trust and very low risk. OMNeT++, on the other hand, is like a massive, sprawling marketplace. It has a gigantic ecosystem of third-party models like INET or Veins. The variety is amazing, but the quality, the documentation, the maintenance, it can be all over the place. And that puts the burden of validating everything squarely on your shoulders.
And this is where the rubber really meets the road. Because during your peer review, you are absolutely going to get hit with that question. With an official, well-documented ns-3 model, your answer is clean, it's simple, and it builds instant trust. But with some third-party OMNeT++ model that a grad student wrote 5 years ago and then abandoned, well, that defense gets a whole lot harder.
Your choice here also kind of defines the type of researcher you become for your project. Are you going to be a protocol surgeon, meticulously tweaking the very DNA of a system? Or are you going to be a systems integrator, plugging together existing black boxes to see what happens when they interact?
And that role you choose leads to two very different kinds of claims in your final thesis. An ns-3 thesis can confidently say, "We went inside TCP and fundamentally modified his congestion control logic." That's a claim of deep surgical contribution. An OMNeT++ thesis, on the other hand, is more likely to say something like, "We built a new system by connecting modules A, B, and C." It's more about the high-level architecture. Both are totally valid, but they are fundamentally different research contributions.
All right, now for the part that really matters. Let's talk about the final boss of every PhD, the peer reviewer. How you survive that gauntlet is often decided on the very day you pick your simulator.
In the world of top IEEE journals, let's be honest, perception is reality. Using ns-3 is kind of like taking the freshly paved highway to publication. The tool is the academic standard, so people just don't question it. Using OMNeT++ is still a perfectly good road, but it's more like a bumpy one with a bunch of gates. You're going to get stopped and asked questions. Which framework did you use? What version? How did you validate it? The bottom line? Using ns-3 just completely removes an entire category of attacks a reviewer can throw at you.
And look, if you only remember one single thing from this entire explainer, please let it be this. OMNeT++ is a phenomenal tool for learning, for exploring, for understanding how complex systems work. But ns-3, ns-3 is the tool that helps you convince a panel of skeptical experts that your results are rock solid and credible.
So let's get super practical. Where are you actually trying to publish your paper? If you're aiming for the top-tier networking journals, I'm talking TWC, TCOM, JSAC, ns-3 is pretty much the expected standard. Why? Because the reviewers there live and breathe deep physical and Mac layer realism. But if you're targeting something like the IEEE Systems Journal, OMNeT++ is actually a great choice because there the focus is more on high-level system interactions. You gotta know your audience.
Let me give you some real supervisor-level advice here. A Ph.D. is already risky enough. You want your work to rise or fall based on how brilliant and novel your idea is. The absolute last thing you want is to get a rejection letter because a reviewer just didn't trust your simulation tool. Choosing the credible standard is all about minimizing that risk.
Okay, we've hit philosophies, ecosystems, and what the reviewers are thinking. Let's pull all of this together into a final, actionable guide for you.
So here it is, the cheat sheet. You should probably be using ns-3 if your work is all about protocol design, especially in wireless systems like 5G or Wi-Fi. And if you're targeting those big-name IEEE journals, it's just the safer, more defensible bet. On the other hand, you should lean toward OMNeT++ if your research is more at the system level, if it involves different domains talking to each other, or if you're just exploring brand new architectures where prototyping quickly is more important than perfect protocol realism.
And remember, a PhD is a marathon, not a sprint. So think about the long-term investment. With ns-3, yeah, you're going to have a steeper learning curve, and it's going to take you longer to get that first graph. But the payoff is a much deeper contribution and a thesis that will stand the test of time. OMNeT++ gets you started faster, sure, but the depth might be a little more moderate. It's that classic PhD rule of thumb. If a tool feels really hard to learn, it's probably because it's research grade.
Now, a quick but really important point on visualization. The animations and GUI in OMNeT++ are fantastic. They are brilliant for teaching and for helping you understand what's going on. But here's the cold, hard PhD reality check. Your thesis examiner and your journal reviewers do not care about pretty animated packets. They care about validated data, they care about equations, and they care about boring-looking graphs that prove your point, which is exactly what ns-3 is built to produce.
So, you've weighed all the options. Now comes the final step. You have to lock in this decision and be ready to defend it from day one of your PhD.
So here's your homework. You need to answer these 3 questions for your research proposal. Number 1, is my core contribution deep down at the protocol level, or is it at the higher system level? Number 2, which specific journals am I really gunning for? And number 3, how am I going to argue that my chosen tool gives me the exact level of detail and accuracy I need to answer my research question?
At the end of the day, this choice is so much more than just C++ versus NED files. It's about defining the kind of researcher you're going to be and the kind of scientific battle you're prepared to fight. You now have the strategic framework, so the only question left is, which path will you take? And more importantly, how are you going to defend it?